This is the second demo that accompanies the database backup types lesson that we've already talked about. In the first demo, we've looked at how you can perform database backups using Management Studio. We've also looked at the risks that you're facing when switching from full to bulk log recovery model and back, and understanding how we can mitigate those risks whenever you think of switching your database recovery models, especially when you're changing anything in the database, not just inserting records, but rather changing the way the database behaves. This demo focuses on one of the uncommon backup strategy types called Multibase Differential backups. I've highlighted a few resources there. One of them is the MSDN resource that talks about Multibase Differential backups. So you can look at this particular MSDN article on how to work with Multibase Differential backups, but I want to walk you through the scenario that we talked about in the lesson on how to work with Multibase Differential backups. So let's start with creating a database to work with. The database that we're going to be working with contains one primary file group with one file, one secondary file group with two files. We're going to create that database, and we're going to be using this database as the basis for explaining how multi-base differential backups work. And start to look at reading LSNs for that matter. I know I mentioned this in the previous lesson. The goal is not to read LSNs during a recovery exercise or recovery scenario. But the thing is to understand how log sequence numbers are being used by SQL Server whenever you're doing the restore. So let's take a look at database properties. So we know that we've created one database with 3 data files, and of course one log file. There are 2 file groups. One's called the primary file group and one's called the secondary file group with 2 files. The first thing that we are going to do, of course, any good DBA would do this, anytime you make changes to the database, is you take a full database backup. This will be the basis of all of the backups that we're going to be taking and restoring down the road, whether it's differential, file and file group, partial backups, and transaction log backups. Note that the message thrown out by the full database backup process contains everything in the database. In this case, it tells you that it has taken a backup of the first file in the primary file group. Of course, we only have one file in the primary file group, 2 files in the secondary file group, and log backup. Again, going back to our discussion on what happens when a full database backup runs. And this is one of those things where it contains enough transaction log to keep the database in a consistent state when you restore from a full database backup. So we're done with a full database backup. We'll look at a differential backup this time. So this is the first differential backup that we're taking after our full database backup. Again, looking at a differential backup, the differential backup based on our discussion of backup types contains changes made in the database since the last full database backup. In this case, well, has almost the same definition as our full database backup. We have the primary file, 2 secondary files in the secondary file group, and of course, the log backup. Let's take a look at taking a file group backup. Now this backup is a backup of the secondary file group, which means it's going to contain files in the secondary file group, which our backup message has specified. You got 2 files in the secondary file group, and of course enough transactions in the transaction log to keep the database in a consistent state, although we're not really doing anything at the moment. But again, SQL Server will always take a look at the transaction log to see if there are enough transaction logs that can be included in a backup. So we're done with the secondary backup, or rather the backup of the secondary file group. We'll take a file backup. Well, since we only have one file in our primary file group, this is no different from taking a file group backup of the primary file group. And again, same thing, only one file in the primary file group, and we're taking file backups. It's only going to contain that file in a primary file group. Let's take a backup of the second file in the secondary file group. Since we're only taking backups of the second file, this is not the same as taking a backup of the secondary file group. Remember, the secondary file group contains two files. In this case, we're only taking a backup of one of the files in the secondary file group. Let's take a differential backup this time. So this is the second differential backup that we're taking. Remember that the differential backup will contain changes from the last full database backup. Now, this is where the fun really starts, because now we're going to look at log sequence numbers and use information from the log sequence numbers and see how we can do a restore strategy based on the backups that we've already taken in the log sequence numbers as SQL Server reads through them. So let's start with the very first backup that we took, the first full database backup. I want you to pay attention to a couple of things here. So I created a very simple format and outline here to guide us and give us an idea of how we can navigate through the different backup media and read through the backups as if we were SQL Server. So this is the first full backup. And we're going to look at two columns here, the first LSN and the differential base LSN, which I'm going to explain in a bit. So we know this is the full database backup. We have the first LSN. I'm going to copy that and paste it here. Now looking at the backup media, I'm going to resize my window a bit here. Looking at the backup media, we know that we have 4 files in the backup media. The size of those files, the create LSN, these are the log sequence numbers that pertain to when those files were created. And then we have, of course, want to pay attention to the backup size in bytes here. We know that since this is a different full database backup, it has everything. That's why you have the backup size in bytes for all of the files. So that's the first, or rather the only file in the primary file group. And these are the files in the secondary file group. What we're really concerned about here is the differential base LSN. The differential base LSN is the log sequence number that is the point of reference of any differential backup. In this case, it's 0 because, well, this is a full database backup. And it's the first full database backup that we're taking. Not really that exciting though. So let's take a look at this first differential backup. Again, we're just reading the metadata on the backups. We know that the differential backup contains all. And again, the backup size proves that indeed the differential backup contains all of the files in the database. And then we have the differential base LSN. Oh, before we have that, let's take the first LSN. Copy that over. So let's say this is 0. This is differential backup number 1. We have our first LSN. And then we have our differential base LSN, which we're going to be copying. And what I want to do is I want to highlight a couple of things as I'm doing this, just so we can use it as a reference. This is the first file in the primary file group. This is the first file in the secondary file group. And this is the second file in the secondary file group. You might be seeing something here, but hold on for a moment. Let's just go and read through the rest of the metadata for the backups that we've already taken. Let's take a look at the file group for rather the backup of the file group that we've taken after the differential backup. So this is file group number or file group backup. We'll take the first LSN. Yeah, this is the file group backup of the file group number 2. Let's take the first LSN and then the differential base LSN. Well, let's name it as this. And then the differential base LSN. Let's take a look at the backup size in bytes. Since this is just a file group backup of the secondary file group, you're not going to be seeing anything on the first file in the first file group, only the files in the second file group. Let's take a look at the differential base LSN. Copy that over. And hopefully I did copy them properly. Copy. It's intriguing how SQL Server actually reads these log sequence numbers as the basis whenever you're restoring backups. Not necessarily how you do the backups in sequence, but rather how the log sequence numbers are chained in sequence to form a backup chain. Rather, this is 2 and this is 1. So that's the file group backup for the secondary file group. Let's continue. Now in the primary file group, we're going to take a look at the first LSN again. First LSN. Oh, by the way, I forgot to mention this. Remember checkpoint LSN, the log sequence number of the checkpoint. Remember we talked about in the lesson on database backup types, where a full database backup will do a checkpoint process at the start of the backup to minimize the recovery process by minimizing the amount of transactions that need to be redone and undone. We're going to be talking about the recovery process in detail in the database recovery lesson. But just to point out that the backup media will contain a checkpoint LSN as a reference point to when the checkpoint started. So this is the primary file group. We're going to grab the first LSN for that. So this is file number 1. The first LSN would be this. Going back to our differential LSN, again backup size in bytes because this is just a file group backup. Well, technically it's a file backup of the primary file group, but since we only have one file in the primary file group, it's just like a primary file group backup and no backups for the other files. Then we'll take the differential base LSN again. And again, just wanting to make sure that we label these properly. Then we go to the last backup that we took, which is, oh, we still have one file group backup. So this is the file backup for file group number 2, which is the secondary file. Again, grab the first LSN. So this is file group 2, file 2, first LSN, and then the differential base LSN for these. And making sure again that we label these backups properly. The last one would be the differential backup that we took, the latest or the last differential backup that we took. Take that. We'll grab the first LSN. which is this. We'll grab the differential base LSN and use that. Now we have a simple map that we can use to find out how SQL Server will read through the log sequence numbers as we're performing a restore using these different backups. Just want to resize this real quick. Looking at the log sequence numbers, remember, when you're looking at the differential base LSN, SQL Server looks at the differential base LSN and looks at the first LSN that contains that particular log sequence number. In this case, of course, we're always going to be starting with the full database backup with a log sequence number, first log sequence number of 92, in which case, if we're going to restore the first differential backup, it's going to require a log sequence number, a first log sequence number containing 92. Of course, all of them are the same. And we know that the first LSN of the full database backup takes care of that. Which proves the point that in order for us to restore a differential backup, we need the full database backup for it. Let's go to the file group backup. If we're looking at a differential base LSN, we know that the differential base LSN for file group 1 will be this. The secondary file group will also be these two. And we're fine. Well, you might be wondering, well, if we're looking at restoring file group backup, we don't actually need this. Because looking at the differential base LSN for all the files, it's actually not the first differential backup. It is the first LSN of the full database backup. Well, let's move on. For file number 1, if we're going to restore this backup, the first file, which is the file in the primary file group, will still refer to 92, which is the first LSN of my full database backup. The secondary file group will depend on this. If you look at the values, I know it's a bit confusing because the differential and the file group both have 34 as the two last digits, but it's actually this. If you look at these two, so the backup that we took for file group 1, or technically it's file backup for file group number 1, it is going to depend on this. So it's really not dependent on the first differential backup. Let's move on. If we look at the file backup, the second file backup for the secondary file group, first file depends on the first file backup that we took. The secondary files, 368 and then 34, depend on this. Again, proving the point that we don't need the first differential backup that we took. Now this becomes a bit more, well, confusing at times, but exciting. The differential backup, the latest differential backup, will depend on 37, which is this. If you look at it, this first file in the secondary file group depends on this. The second file in the secondary file group depends on this. Now wait a second here. I thought for a while that differential backups contain the changes made since the last full database backup. Isn't that the definition after all? In this case, if you look at the differential base LSNs, there is nothing in here that pertains to the log sequence numbers or the first log sequence number of the first full backup that we've taken. Let's prove the point. First, let's go back to our demo and see if that proves the point. We'll drop the database and we'll try to do what we probably would do normally, and that is to restore the latest differential backup. Of course, first with a full database backup. So let's start with restoring. Of course, I have to drop the database just in case I don't want to overwrite it. Let's restore the first full database backup. Of course, using the with no recovery option so that we can restore backups, subsequent backups after the fact. And let's restore this. This is the first instinct that DBAs would probably go after. Look at the latest differential backup and restore that immediately after the first full database backup. Like, whoa, that doesn't look nice. If you look at the error message there, it says the differential backup cannot be restored because the database has not been restored to the correct earlier state. Does that mean that the differential backup definition is not correct? Well, it is still correct, but however, in this case, we can't just take the latest differential backup and restore it on top of the full database backup, primarily because we have series of file and file groups or partial backups that are running in between the differential backups. In order for us to really understand how the correct sequence of restoring the backups is, we have to read the log sequence numbers. And of course, as I mentioned earlier, it's not supposed to be we're not supposed to be reading the log sequence numbers when we're doing the recovery of a database. This is the last thing that we're supposed to be doing. Because if you noticed, it took me quite a while to recreate this map and try to differentiate which database backups I need to restore to make sure that I follow the correct sequence. Now, what would be the right sequence in this case? We know that we can't just take the full backup and then the latest differential backup if we have file and file group or other partial backups running in the mix. But since we already have a mapping of the log sequence numbers, we know that if we need to efficiently restore this, we'll start with the full database backup. We can skip the differential backup here because if you look at all of these, this one relies on the full database backup. This backup relies on the file group backup for the secondary file group because of the log sequence numbers. So this one refers to the first full backup and these two refer to the file group backup. None of these subsequent backups depend on the first differential backups. So in order for us to restore the latest differential backup, we need to restore these three. Let's try that. So we know that we can't just take the latest full database backup, or rather, we can't just take the latest differential backup and restore it on top of the latest full backup. We have to know what other backups are in place in order to properly restore them in sequence. Don't be surprised if you see something like this in the error message. It just means that you're not restoring the correct backup sequence. So as I mentioned, to find out the most efficient restore sequence, we need to know what else is happening in the mix. This is one of the things where I say, well, take a look at your backup history. Maybe there are some backups running in between your full, your differential, and your log backups that you're not aware of. Maybe some developers have taken a full and a file group backups in between without you knowing. So let's drop the database and restore. Again, going back to what we've done earlier, we'll restore the first full database backup. After that, we're going to restore the first file group. Note that I'm actually following this. I've skipped the first differential backup because it's really not necessary for me. We'll restore the first file group backup, which contains the file groups in the files in the secondary file group. And then we'll restore the file backup of the primary file group. Again, this is just a relatively empty database. We'll restore the file backup in the second file, or the backup of the second file, that is. And if you look at the restore message, it will tell you what was restored in the process. Let's restore the differential backup. This is the latest differential backup that we took. And now it works. Unlike the previous restore process that we did, where we only took the latest differential plus the latest full backup, which didn't work because the log sequence chains are not properly set and they're not in sequence. It's important for us to understand how SQL Server restores the database or reads the backups and create the proper restore sequence based on the log sequence numbers, and of course restore the database, and the database is back online. Bottom line here is, remember the topic on a database backup strategies, you keep it simple. Aside from meeting your recovery objectives, you keep it simple. Plus, understand that there might be other backups, out-of-band backups, that were taken by somebody else that you're not aware of. Remember to regularly check your MSDB database for your backup histories so you're aware of whether or not this particular backup strategy works without breaking the log sequence chain. So keep in mind, though, again, make sure that you simplify your backup strategies to make sure that your restore strategies will still work, and make sure that you test them on a regular basis. Don't just fall under the impression that the latest differential backup with a full database backup would be enough, because you'll never know if somebody else took some partial backups that you're not aware of. I'll see you in the next lesson.